Hi everyone, today we are going to talk about the first two steps of the free radical substitution mechanism. Alright, so before we tackle this mechanism, we need to understand the goal behind each of these two steps. So the first step's goal, alright, is to form our radical. Right, so what exactly is a radical? So for example, Cl, if Cl2 breaks apart, it can form two Cl radicals. Alright, so this means that chlorine now has 7 valence electrons in its outer shell. Alright, so what we need to do, okay, is we need to draw our half arrows, okay, to show that it is a homolytic fission, which means both of them gets 1 electron each. Okay, so let's take a look at this question. Alright, so in the first part, we have Cl2, we have UV. So in the initiation step, Cl2 will break apart. Okay, take note of the half arrows under UV to give you the Cl radical. Okay, so how many radicals do we have? We have 2 radicals. Okay, so this is the first step of our mechanism, which is initiation. Alright, so let's move on to the second step, okay, propagation. So the goal behind it is that we need to be able to form our product, okay, and how it works is that we need to take a radical plus a molecule to give us a molecule and a radical. Right, so this means propagation, the reaction continues. Alright, so this is how the reaction can continue. And what we need to point out later is which is the more stable radical, and we also need to take a look at the half arrows. Alright, so usually we don't draw the half arrows, but just remember that there are a lot of homolytic fissions and fusions over here, so half arrows are moved all the time. Alright, so let's take a look at the propagation step here. So right now I have this molecule here. Okay, I react with the only radical I have, right, this Cl. So the radical has to take away one of the hydrogen atoms. So in this case, I can have a hydrogen atom here. I can also have a hydrogen atom here or here. Okay, but in the previous lesson, we know that these 2 points are equivalent. Alright, these 2 hydrogen atoms, or rather these 6 hydrogen atoms, are all equivalent. So what this Cl can do is that it can take away either this hydrogen or this hydrogen. Alright, you will take away this to form either a radical here or radical here plus HCl. Alright, so how do I draw this out in my full displayed formula? Okay, how do I get this radical? So assuming I'm taking away this hydrogen here. Right, so this radical, okay, will take away this hydrogen and form a radical at this point. So what I will get at the end is this, right, because of a lack of one hydrogen. And of course I have my HCl molecule. So can you see that we have now reacted a molecule with a radical to form radical and a molecule. Alright, so this is our first propagation step. But of course, this does not give us our product. It does not achieve our goal, so we have to continue. So let us pick this radical here. Alright, I'll explain why I will pick this radical later on. Alright, so with this radical, I will now react with another molecule. Alright, this time around with my Cl2 that's present. Okay, because this is the only way that I can form my product. I will get Cl attached here plus a Cl radical. Okay, so once again, radical plus molecule gives you molecule plus radical. Alright, and have we obtained our product? Yes, we have. So we have achieved our goal here. And notice Cl was formed here. Cl was used at the start. So in the propagation step, the Cl radical, alright, is a catalyst. Okay, so this is one of the important points that you need to take note. Alright, so let me move back to why I chose this radical here to continue. Alright, so this radical here is our most stable radical. Right, so how do we explain its stability? Okay, so let's take a look. Alright, I have this radical and this radical here. All right. So the more stable radical will be formed easier. All right, will be formed easily compared to the other one. All right. So if we take a look at these two radicals here, we know that radicals are electron poor. Alright, so it has a lack of electron, that is why it is so reactive. It wants to take in another electron from a molecule, maybe by taking a chlorine atom together with its electrons, or from a hydrogen atom. Alright, so they are electron poor. Therefore, what we want to do is we want to stabilize it. Okay, we want to make it less electron poor. And as we know, the alkyl groups connected, alright, they are electron donating. Right, so these are electron donating groups. Alright, so look at the direction of arrow, they are donating electrons to this electron poor region. And what we can see is that this secondary radical, alright, is able to has two electron donating groups. Alright, while this only has a primary radical only has one electron donating group. So this means that the secondary radical, the one on the left, is more stable because it is less electron poor. Alright, the radical is less electron poor. So this is how we can answer the first two steps of this mechanism: initiation and propagation. Alright.